Hello, welcome back. Today on the bench we have a piece of radio magic called a Compeller. This is made by Aphex Corporation, and I believe this one's from around 1987. Been in use full-time ever since then. And what this is an audio processor, a special kind of audio processor. If you listen to radio back in the old days, or TV even more so, and you're old enough, you might remember a thing they called a wall of sound. Well, basically what that was a compressor and expander that would drop the sound down to a particular level through the compressor. When sound went into it, and then when there was a blank spot or a low sound, it would try to pull the sound up in an effort to try to even out the level of sound. This worked as long as your material was fairly constant. There was always sound of some sort. If you listen to old TV and stuff, you'll realize that if they did it right, you would have more or less a constant level of audio. When they stopped, however, stopped talking, the sound would slowly rise, and it'd go from nothing to whoosh, and you'd hear this hiss and noise, and whatever was in the background just came up and matched wherever it thought it was supposed to be. And then when they started to talk or some noise in the background, it would go from this level and thump down to the bottom and back down to where it was. And that is a very disturbing sound. One of the purposes of this machine, this piece of equipment, is to try to limit that rising up of sound to a level of 0 dB or whatever they've got it set to, and lowering it back down very rapidly, both rising rapidly and dropping rapidly. I mean, in the old days they rose slowly to the point of, the 0 dB level with the noise in the background, picking up whatever you could, and then as soon as they started to talk, it would slam down and thump in, so that it was this is supposed to limit that. And we'll do a little demonstration here and show you, but this also has a couple of other things that it does. One of the other things is that it can be used, it has the expander and compressor built into it with a time base so that it'll slowly rise and fall. It also has what they call, if I can read this, silence gate, that if there is silence, it will shut off the compressor and expander so that the thing doesn't rise up at all and try to bring in all the background noise. So you get a much more natural change. And it does all this over a period of time so that it doesn't respond instantaneously to the rise and fall of sound. It also has built in a stereo enhancer, they call it, which sort of separates the stereo, at least the way you hear it. But in doing that, they also didn't mess up the monocentric channel, so that if you're listening on a pocket radio or something, you don't get this weird phasing of sounds that you get. Speaking of which, if you've ever listened to a radio station or your stereo or something like that, and it was playing along fine and you could hear everything, but it just sounded something was maybe a little bit wrong with it. You couldn't really hear the people singing that well. They weren't as loud as the music was in either channel, or you got a commercial comes on and you can just barely hear it and the guy sounds like he's way in the background kind of talking. What that basically is the material that they were using on air or on your stereo. Well, mostly on air it would happen, especially in a mono radio, was out of phase. What that means is that the left stereo section, not on this piece of equipment, we'll put this down and go on with the talk, the left input was doing its sine wave like this, while the right input is supposed to like this. Well, if you're out of phase, see if I can do this. The right input, or the left input, is coming up while the right input is going down. So it kind of goes like this. Well, what you end up with is where the two meet is nothing. So you end up with no audio here and in the center, and then audio on both channels. If you do, the easy way to do that on your stereo at home is to hook your speaker wires up backwards. So if you've got plus on one side, minus on the other, and plus on one side, minus on the other, then you're going to get sound out of both speakers, but you're not going to get this center portion because it's out of phase. And you'll hear that sometimes on commercials and things. Not so much anymore because everything is done through computers, but every once in a while I'll hear it, or we'll get a spot or something in at the radio station that is out of phase. And we have to correct that by taking it, separating it, flipping it over, and whatever, and getting it back out there. But anyway, if you ever hear that, that's what that is. That has nothing to do with this. That's just a little knowledge. Anyway, so that's what this is. And we're going to check this thing out and see what it does. I've got my 1710 distortion measurement system sitting over here being used as a basically an oscillator, an audio oscillator. And I've got the output is ganged together and plugged into an old ICO 150 solid-state signal tracer, which is a great little device. So we'll turn this on. There, just barely. That should be enough for you to hear it. And we'll turn this guy on. All right, now, if you look, if I can get this good enough, I think I can. You notice over here we've got a couple of dots, and over here we've got like one dot over here, which I can adjust. And here's what happens. I'm going to adjust the input on this side. Well, let's start with this side because it's working better. I'm going to adjust the input on this side and bring it up and then turn it down. You'll notice that it slowly drops away. What I'm looking at here is the output level. Over here you got a switch for looking at input and looking at output. And when I bring it up, okay, turn this back down. When I bring this up, it comes up pretty quick, but then when the audio goes away, it drops pretty slowly. That's working the way it should. So let's get this back up to 0 level. Now let's check this side and see what it does. If I bring it up, up it goes. Drop it down, down it goes. Like it's supposed to. Okay, so the input section is working approximately all right. Let's get these back to 0 level here. Come on, baby. Whoops. Wrong knob. Alright. There. Alright, now we're going to do the same thing. However, I'm going to do it. Oh, by the way, this has a bypass. You can just bypass everything here. What I'm going to do, or notice here, there's a little light up here for silent sense. So what I'm going to do is I'm going to quickly turn down the input to it and see what the channels do. They should do about the same thing that they do when I'm, turning up and down the knob, but let's find out. It's down. This one dropped off like it's supposed to. This one did not. Okay. And the silent sense light came on. Now, we can do the silent sense light to vary between 0 dB and minus 40 dB for where it wants to sense the silence. But if I take this back up comes the lights where they're supposed to. Turn it back off again. Silent sense comes on. These lights do not drop like they're supposed to. So it's seeing this side, but it's not seeing this side when the input drops pre this. So basically what I've got in here, I believe, is noise. We'll check that out. For right now, let's open this thing up and see what's in it. Ta-da! It is a mass of stuff. This is pretty old technology. Like I said, it's 1990. 87, I mean. And it's all through hole components. I don't see... No, there isn't a single feed through or surface mount on this in this entire box, which kind of expect that. So I believe what we're going to find out is it needs cap replacement. What do you expect? It's 1987. So anyway, I'm going to take this thing apart. It'll give you a little better look at the inside of it here. This is the inside. It's basically just all ICs, transistors, resistors. I mean, just regular, normal stuff. A couple of big ones here, big ones over here, and they're all, here's some good-sized monsters over here. Low profile. Those would be interesting to find if they're bad, which I'm sure they probably are. But we'll see. We'll get this thing apart and see what it looks like on the inside underneath these boards. We'll be back. Okay, well, we have the power supply board out and the other boards over here. These are the other boards that go across the top. We got this power supply board out of here, and we're going to check the capacitors. These are Nichicons, so there's a pretty good chance they're okay, but let's find out. I'm on the automatic check for okay, so this is saying it's 2.3, so 2.2 2,200 microfarads at 25 volts, and it's saying it has an ESR at 26 ohms. That's way too high. Okay, so let's check the other ones. Even Nichicons go bad after 20 years. Wait a minute, 87, 97, 07, 30 years. 30 years. Oh, Lord. That's actually depressing. I'm going to have to, if these are bad, which I'm pretty sure they're going to be, I'm going to have to order them because I haven't got anything that's this. Boy, those are big leads on the bottom of these guys. and really jammed into the holes pretty good. This is a double-sided board, so I kind of got to be careful that I don't rip the feed-throughs out. Alright, so this one, we are going to, what is this? This one's 2200 to 35 step. Yeah, nothing. Okay. Just checking. So, hook this one up, and it says, yeah. Yeah. I think yeah, Houston, I think we have a problem. It won't even read it half the time. 2 point. Really? Let's just take this back over to here. I have a bad cable? I don't think so. Nah. If you hit the transistor mode, it's just all over mode. Yeah, this thing's saying 42 microfarads at, oh boy, 1.4K. Or 0.14K with 140. That's basically as good as bad as this thing will do. So let's try this one. Like I thought, this thing is, it's just going to need a complete recap. There's a lot of them. Let's see what this one says. Probably about the same thing. What? That can't be right. Okay. No. Just no. I think there might be something wrong with my little box. Darn it. Alright, let's put it on. See what the regular meter thinks of it. It thinks it's a diode. Okay, I have never seen this before. Turn it around. Yeah. It's about a 1.8 volt diode. Okay, I'm gonna check with different leads. This this is a new one. Anybody ever seen this before? Honest, folks. Okay, that is completely new. Let's try it. That's a capacitor. It is not a diode. Okay, I'm going to hook it up to these two leads. It won't show me ESR with these leads. Well, it does show me ESR. 89 microfarads, 0.14K. And let's check this with the meter. I mean, I expect to get it to basically maybe beep real quickly. And that meter's showing just open. Okay, that is a complete new one to me. Let's try that one more time. With completely different leads this time. Hooked up. See? And push. Yeah. My capacitor is showing as a diode. At what? 11 microamps, 158 millivolts. That's a new one to me. I've never seen that. Well, okay. So we got diodes, capacitors to replace. That's just interesting. Well, I don't have anything like this 2200 at 35 in short format, so I'm going to have to order those. So this thing's going to have to wait until I get the parts in. We'll be back. Hello, welcome back to my shop. Well, I got me in a passel of capacitors. Bunches of them here. They're all of these are destined for these compellers. I got a bunch of these, several. And since they've all been sitting around for about the same amount of time, I figured, what the heck, let's do it. I even got a bunch of tantalums to replace the tantalums that are in here. Took a few days to get them, but I had to be very careful when I chose them because I didn't have a lot of spare room. Here's the originals. Matter of fact, here's the capacitor that checks like a diode, and here's the ones I got. Now, they're newer, so they're smaller a little bit, but the lead spacing is the same. Yep. Which I had to be very careful about. The height's a little less, which that's okay. I can live with that. And then I got yeah, these guys, which are the same but go on a smaller spot over here with different lead spacing. These are 2200s and this one's 2200 at 35 volts, but they're not the same lead spacing. So basically fits like a glove. Yay. Just for grins, I did buy good ones. I don't buy cheap ones when it's something that's going to be online and running 24/7 for the next 20 years. So just check them and make sure they're good. And what they got, yeah, there we go. 2336 microfarads at 0.01 ohms ESR. Good enough for me. When you buy capacitors for a project like this, make sure you buy the good ones, and make sure you do your homework on the lead spacing, because there's nothing quite as annoying as getting capacitors in that don't quite fit and or are too high or won't fit in the space provided. You know, it's aggravating. So do your homework. It only takes an extra 10 minutes of your time to be online and look for the right ones. Here's the other ones. Different lead spacing on these. And plunk right there in the hole, and it's perfect height. Alright. These are, I believe these are Rubicons. I didn't have a lot of choice on some of these because of the weird sizes. So I had to go with what I could, but most of them are Rubicons. Yeah. Rubicons or Nichicons. Those are Rubicons. These are axials, and they're Nichicons. These are Rubicons, and the big box of these little guys is Rubicons. And these are, well, these are Mallory's. These were the weird ones. Yeah, 33 or 330 microfarad, 20 volts, or 35 volts. They didn't have anything else in this spacing and size, which I have to replace on this board, so I ended up getting Mallory's on those. But I suppose they're okay. I mean, they are a relatively big name. Well, they used to be, anyway. This board looks like they attempted to conformally coat it, but didn't bother to do a very good job of it. Interesting. We got them all in. Plus yes, plus yes, plus yes. Double check. Wow, where'd my little bucket of cut off leads go? Okay, so that guy's good. We can put him back in. This thing's got lots of voltages in it. I mean, this is kind of interesting. What's that? That's a 7815. I don't know. There's 12 volts and 15 volts, 9 volts and 8 volts, and yeah, all these different voltages for this one box. I'll just put this board back in, take one of these other ones out, and see. I'm just going to recap the whole thing anyway, because, like I said, it's going back into service, and it'll be there for the next. Okay, so you don't want to go in there. Why not? No. Oh, there it goes. Never fails. Alrighty, so, and of course I put it in backwards. Of course I did. Watch what you're doing, David. Should have noticed, since nothing fit quite right. Get that on there because it's hard to do when it's in here. Okay, so I'll leave those. Now we can put these on here. All keyed. That's nice of them. Yeah. I like it when a plan comes together. Okay. There. Alright, that's in there. So, let's start with this board just because it's the easiest one to get out. Now, well, let's see, which one is it? This one? No, it's the next one, of course. It is. No, it's not that one either. Why is it always the one you can't find? Okay. Carefully, so as not to bend the little leads on it. Are you gonna let me take you out? Nope. So I actually do have to take these off of here. Oh, interesting. I guess they wanted to make sure it didn't fall apart. Sometimes it does amaze me when I go through this stuff, how many screws are on something to hold it together that's going to be sitting in a rack and never touched. Because that's the way this stuff works. It actually gets set in the rack and literally never touched. That's why sometimes, well, a good amount of the time actually, the switches go bad in them because the switches just sit there, metal against metal, and well, they do a combination of things. They'll eventually will flow, the metal will flow into each other even though it's not under much pressure, and they'll oxidize or create a layer between the switch contacts that you can't get off no matter what. Oh goody, there's no caps back there underneath that little plate. Anyhow, let's see. Take out a couple of interesting little bodge wire there. I guess they figured right there. I guess they figured it was just too hard to get around it. Well, it would have been. It truly would have been hard to get around it. Yep. Yeah, so they put the bodge wire in. Alright. Now let's see. Let's take one of these guys off. Be interesting to see if they're any good or not. They mark plus? Yes. Okay. So, here we go. What does it say? I only got one camera with me today, so I'll just have to tell you. Well, it says it's 116 microfarads at 0.14 K. That is a toasted leaky capacitor. Yep, reads twice the same way. So this one is 100 microfarad. It's 25 volts. That's what I got, the big giant bag of them. Looks like I was right. Every last living one of these is going to have to be replaced. bet you I'm not going to find one that's any good. When I do a whole lot of caps like this on the board like this, I'll just stick them in and flare them over. That way I know which ones I've done and I don't have to go back, because these are real similar to what's in here. I guess part of that comes from my old days of building Heath kits. You put in 9,000 parts and then solder them. Because if you did every one of them every time, you'd kill yourself. Oh, this one's not terribly bad. This is 97 at 0.38, so it's not horrible, but you know, I'm gonna replace it anyway. I'm not forgetting to put the budge wire back on. And yes, I did measure the lead length on these. Let's do another one here, just to see. Let's see what this one is. Yeah, this is 89 at 0.48, but a 5% loss. So, yeah, I'd say it's just replace them all and don't even think about it, but I will check them just because I'm interested. Anyhow, I am not going to make you suffer through this whole thing. Take one of the little ones out here and see if it changed at all. These are 22 at 25. We'll try one of these too, see what it says. Well-made board, I'll tell you. And they're all marked plus and minus. That's nice. Because you know, you're sitting here doing this stuff and the board's not marked and you just pulled out a cap. And then somebody pokes their head in the door and says, "Hey Dave," and you forget where everything went. Then you're in trouble because you can't remember. Yeah, there we go. It says it's 208 microfarads at 0.14K. And it's supposed to be 22 microfarads at 25 volts. Let's try that again. Ah, there we go. Hey, it's still bad though. I always check them twice. It's still 9 ohms, almost 10 ohms. So it's 22 microfarads. I don't know when the heck it did that, but man, it's reading weird. I wonder if I got bad leads here. Ah, give me a break. Try it again. Yeah, there, 22 at 11. Yeah, so it's bad too. So, it's all of them. I'll be back when I get them replaced and we'll see if it fixed the thing. Okay, so there we go. All the capacitors have been changed and it appears to be working. Let's take this thing here. I'll pause this for a minute. So, it appears to be working, like I said before. If we take a look at it here, we can see I'm feeding it 0 level into both inputs. And we'll take a look at the input here. That one says 0, that one says 0. That's perfect. The output, I've got it turned up to where I want the output to be, which is 0 level on both of the outputs by putting this switch in output. And I'm in program right now. Let's go into gain reduction. And as you can see, it's off a little bit on one side here, but they're a little bit different from each other, but these always were just a little bit different. It is turned on. And if I go over here, let's watch this one. See how slowly it goes down? I just cranked it down. Oh, what is it? Minus, yeah, about 8 dB. Bring it up to 0 again. And see how slowly it moves? Well, that's taking it down real low. And as you can hear, we'll bring the level up. We'll take this down to way down. Pull the level in the amp way up on my little thing there. And we'll adjust the sensitivity for when it takes over. Once you hear this, hear that? That's it pulling up the noise. And when I put it in, all of that noise goes away because it's not, I've told the threshold to be at a level, a certain level, and when it gets to that level, it will go into silence. That's what makes these so nice. They don't just raise the level up, and just up and up and up and up and up until you just get this wall of noise. So, what we have here, cut that down a little because that's going to get real loud. Okay, so what we have here is a working Aphex Compellor, just like it's supposed to. And all it took, what did I count? Well, let's see, 2, 4, let's see, there's 11, there's 20 in that, 40, 2, 4, 6, 8, 52, 54, 55, about 55 capacitors, 52 capacitors total. But hey, it's done, it works. We'll put it back in and I'll get another one here. Just to show you what I mean by the gate, I'm going to cut down. Watch this right here. It kind of looks red on the camera, but it's not. Watch that, and I'll cut the level down. I've got this thing set for between 0 and 40 dB, the halfway mark for the threshold. Now, when I cut the level down, watch that silence gate. There, silence. Now, if I turn the silence gate down or up, give it a little, turn it up to 0 dB until I get to 0. That's minus 20. Till I get to 0. When I get to 0, that's 0. So it will, at 0, it'll quit working. It'll quit trying to raise the level because it thinks that 0 dB is the gate. Now, if I turn this down to 40 dB, negative 40 dB, that thing won't come on until I get to negative 40. That's negative. There's 20, 30, 40. Well, oh, it is on. I just couldn't see it. Yeah, it's on. So take it back up. There's 30. So, and it should cut in here in a second. There it is. So it's working. You set this where you want the noise threshold to this thing to stop working to raise the background noise. Anyway, and the stereo enhance works. We got her. Yes, we do. 52 capacitors. Now, only 6 more of these things to go. Thanks for watching. Don't forget to subscribe.